So today calculus 1. There's a few rules: power rule, chain rule, quotient rule, and product rule are in the previous videos. Start with the chain rule. Chain rule is for composite functions. If you know how to work with composite functions or how to recognize a composite function, sort of like a system of equations, except instead of two equations, one on top of the other, it's one inside of the other, not one next to another. Like the product rule, you would see is a f of x times g of x. So you have, this one term, this number two term, you multiply. That's the product rule, the quotient rule. Similarly, you have the two rules, but one is on top of the other instead of next to the other. So with the chain rule, you're dealing with a function that is actually inside of the other or outside of the other. However you choose to look at it, it will usually be written in my videos as f of x and g of x. So when you have an f of x equation, what I mean when I say one function is inside of the other, I mean you're taking one function and plugging that function in for the x value in the other function. So, or y value. If you have f of x or f of y here, these are two different functions. One is in terms of x, one is in terms of y. Now, if you want to incorporate g of x and g of y, you can easily incorporate this into a composite function simply by taking the y value and pulling the g of x from the entire equation, g of x, into y value of f of y or f of x, g of x. It doesn't matter. You can, similarly to the g of y into the f of y, you can plug in the g of x into the f of x, but also if you're dealing with multivariable equations, you can, well, I guess this wouldn't even make a multivariable unless g of x includes some y value. That would actually make a gxy equation. So you can also, plug in gxy into f of x. So that is a review of composite functions. That's what a composite, when I say composite, that's what I'm talking about, is a like plug in your function to your function is this. Oops. Gonna get rid of that. And gonna get rid of that. So, chain rule with a composite function. We'll work first with the definition. If you have f of g of x, the derivative of f of g of x, the entire thing, is going to be, you're going to take the derivative of f of x, where we'll say u, we'll put this actually in terms of u, where u g of x are equal. So you will actually take the integral of f of u, sorry, not the integral, the derivative, f of u, multiply this derivative, which is the outside, is how you would, excuse me, sometimes hear that expressed is in terms of the outside function. So you take the outside function, you multiply it by the inside function, and you get a chain rule from that. It is kind of, I guess it's like I'm not sure why it's called like the chain rule. If it's like if it's kind of like just evolved like that, way over time is I'm not too sure, but it's definitely used a lot alongside of the product and quotient rule. So after you take the derivative of the outside, you take the derivative of the inside and multiply it. So outside times g prime of x. And this is the chain rule. Okay. I'm going to give you a second, write this down. You will need this. If you're taking calculus currently, you will need this in your notebooks if you have already taken calculus. It is good to refresh your memory with the equation. So once you have the equation, you can actually solve a dilemma. Let's say a dilemma. You will not often see word problems involving calculus. If you see a word problem involving calculus, you have most likely stumbled upon a physics problem. Or sometimes they also put those in the micro and macro economics textbooks with calculus integration. You will see the mix of word and math equation problems. For today, we're just going to be solving regular equations. So, example number 1. Let's start with x. We'll do 2x plus 3. Let's make this squared and let's add an x here. Alright, we can square this. So here we have our composite function. One way that you could do this, if you wanted to, is to multiply out the equation 2x squared plus 3x times 2x squared plus 3x. So you just multiply, distribute your two terms, and then the result would just lead you to taking the derivative of each individual term. You would result to something like ax squared plus bx, in which case you can take the derivative individually, which we know how to do, of each of these terms. So that is one way to do it, but that can get very complicated if if you're working with pen and paper. You're going to run out of space very quickly. So this is why we have the chain rule, is to look at this in a much simpler simpler way, so that we can solve equations without running out of paper every time you want to solve problems. Let's get started. First, we need to take the derivative of the outside. So the outside equation here is x squared. Here's our x squared. See that in blue, royal blue 2 so our first equation, x squared. The derivative of this is an easy 2x. And if you remember, where this is our x multiplied by 2, we have 2 times 2x squared plus 3x. And then we get rid of the 2, that turns into a 1, subtract the 1 from the exponent. And this is what we're left with. Now, if you remember, the next step is to multiply. Sometimes you might get mixed up and you might want to use addition instead of multiplication, but you will need to use multiplication for the chain rule. There's no addition typically unless you're dealing with multiple terms that you will see once you get to implicit differentiation, dealing with different variables. Then you'll be forced to, if you were to expand a polynomial, use different variables that would cause that to happen. So when we multiply by the inside, derivative of the inside, this is our g of x take the derivative of 2x squared is 4x plus 3 is going to be our derivative of 3x and here is your chain rule. Multiply the 2 and you'll have your result. So sometimes, most of the times, it is useful to simplify your equations into a form that is easy to work with. This equation is, as you can see, we have a 3x and a 4x, and you have the different equation. You can simplify this into much smaller equations or operations. You don't want to have to look at multiple operations in your answer. You want your answer to be your answer. You don't want your answer to be, oh, here's your answer. However, there needs to be like 3 different things done before it's actually an answer. That's not an answer, so you're not gonna do very good with your classes. So simplify. I'm not going to do it for you. That is something that you should already know how to do. So that's the chain rule. We've gone over the product rule, quotient rule. The chain rule is a very important one. I'll write the equation up here. Formula over here one more time. Prime of x, move the x, and you get g of x here. Derivative of the outside times derivative of the inside. One common error is that sometimes you will see that someone takes the derivative of the outside. So f prime of x, where f of x is the outside. It's outside. G of x inside. So the common mistake you'll see here, where the x would normally be just the inside function, would normally be g of x to follow the chain rule. F prime of g of x outside with the inside here times derivative of the inside. So basically, you just want to make sure that you keep the original g of x inside of the brackets here, and then you multiply out the derivative. You don't want to change. Sometimes you might want to take the derivative of the outside and then change the inside to the g prime of x, and you don't. That's not usually that useful. I mean, you can do this and work through a calculus problem and some methods of solving, but this very niche method for going about an equation and takes usually too long. So if you want to follow the chain rule, which most professors will expect to see on an exam, do not do this. Multiply that out. F prime of x, g prime of x, g prime of x, and f prime of x. Keep gx regular on the inside. That is our chain rule. Okay. So, if you have any more questions about the chain rule or product rule, or quotient rule, or any of the general calculus terms that I've gone over so far, just let me know. Comment, subscribe, make suggestions that will benefit the greater good of this video series. Thank you, and enjoy your calculus.